Today we're looking at circle theorem. That's the topic for today. I want us to take a look at the assessment. So let's do that. Okay, this is the assessment for this week. It's due next week Monday, and you'll have to learn some concepts or some ideas, theorems that are associated with circles. Okay, these are facts that relate to circles, things that you just would need to know. Okay, you have the technical definitions here, and I'll try to put it in my own words afterwards. Okay, the first one is called the angle at the center. It says the angle which an arc of a circle subtends at the center of a circle is twice the angle it subtends at any point on the remaining part of the circumference. Okay, so that's the technical definition. The angle which an arc of a circle subtends. Now, what does that mean? So if we look here, we see that these two angles, this angle touching the circumference and this angle at the center, are both standing on an arc. So it's standing on an arc. An arc is just a portion of the circumference, just a portion. It may be small or large, but it's a portion of the circumference. So the angle which an arc of a circle subtends at the center of a circle is twice the angle it subtends at any point on the remaining part of the circumference. So they're crediting this arc here with producing this angle. And since both of these angles are standing on the same points related to this arc here, this arc is being said to be the reason for this size, the sizes that you see here. And the relationship that we're supposed to focus on is that the angle at the center is 2 times the angle at the circumference. So what does that mean? That means that if the angle here would be, for example, 300, let's say it was 300, right? What would be the angle at the circumference? Can anybody figure that out? If this angle is always 2 times the angle at the circumference, and I'm telling you this is 300, what would be the angle at the circumference? Okay, let's put it a different way. Suppose you knew the angle at the circumference, and you knew that it was, for example, 60. What would be the angle at the center? Anybody have an idea? If this is 60, notice here, let's take a look here. Okay, so if we have, okay, we have a circle here. It's going to a point at the center, just estimating there. Have you guys ever done anything like circle theorem before? Or is this the first time you're seeing this topic?
First time, sir.
Okay. So remember, these are just rules. You don't have to prove anything, but you'll use these rules to make your proofs, to prove and show your answer. Okay, so I said 60, right? So if this is 60 and we want to find x, this is at the center. Okay, so and let's label it um, P PQR. So let's say we had um, the angle. We're looking for x, but we're gonna state something here. So x is going to be 2 times the angle PQR. Okay, and what we see there is that this is only true because by what is this called? What was that theorem called? Let me see. It was called it's called angle at the center. So that's the name of the theorem. Okay, so by angle at the center. So that's why we can state this. That's why we can't just write it down. We have to state the reason for it. Okay. All right. So this is the reason for us to write this. And what is the angle PQR again? What would that angle be? PQR, and we always focus on the center letter here. The center letter tells us the angle that will be our focus, and so our angle of focus will be
60.
60. Very good. So that's our angle of focus here. And 2 times 60 will give us the value for x. Okay, so 2 times 60 is
120 degrees.
all right, 120 degrees. Very good. All right, so that's how you would demonstrate or show um, and apply the theorem to find your solution. Okay, let's continue to look at different examples here, or different concepts here for circle theorem. So now you guys understand the first one, which is angle at the center. It's always 2 times the angle at the circumference once both angles are standing on the same arc. Um, the next one says is a similar idea. 2 angles are standing on the same arc, but this time both angles are at the circumference. And when that's the case, both angles are equal. Angles in the same segment of a circle and subtended by the same arc are equal. So if you were to draw a line from one point to the other here, you would form a chord. That line would be called a chord, and that chord would divide the circle into a major segment and a minor segment below the chord. Alright, so that's what they mean here. Both angles are in the same chord. The same segment. And that's the case here. And subtended by the same arc, which is this arc here. So this arc applies to both of these angles. They're both standing on the same arc, and because of that, both angles are equal. Okay? Any questions? The next one is called angle in a semicircle. The angle in a semicircle is a right angle. So that means a semicircle means half of the circle. So we see a triangle formed here. This triangle is in half of the circle. And what this is saying is that if I were to take this point right here and slide it down or slide it toward the left, the angle that would be formed would always be 90 degrees, no matter how the triangle is transformed. It would still remain 90 degrees at that point. Okay, so that's the rule here. Angle in a semicircle is always a right angle. Okay, now the last concept for this assignment is called cyclic quadrilateral. It says the opposite angles of a cyclic quadrilateral are supplementary. And what does supplementary mean? Have you ever heard that term before? Supplementary angles? Are you familiar with that term? It just means a straight angle, or in other words, 180 degrees. So whenever you hear the word supplementary, just remember it means 180 degrees. Okay. Remember, you can, if you have any comment to make, you could write it in the chat. The next portion of this concept here is called, relates to exterior angles. So what's an exterior angle? Those are formed when you extend one of these sides outside of the circle. You form an exterior angle. Now, if I was to extend this side here, right? Say I was to extend it, I would form an exterior angle, right? It would form here, right? Imagine I'm extending this line. We would form an exterior angle. This theorem says the exterior angle relates to the angle opposite of it, the interior opposite angle. Now, what is the relationship they have? It says that they're equal. So, if I was to form an exterior angle here, which of the four angles would it be related to? So imagine I'm extending this here. Which of these angles is the exterior angle related to? Is it related to A, B, C, or D? Right? Extending,
E.
it would be related to B, because that would be opposite of this exterior angle.